Math 3, Unit 4 test review. This first question that we're going to talk about, and if you have out whiteboards or scratch paper, you guys can do this on your own as I'm going through it. They're going to ask you questions about the vertical asymptote and the horizontal asymptotes. So there's going to be 5 questions where you're doing true and false to this. My suggestion is, looking at this problem, write down what the answers are for the vertical asymptote and your horizontal asymptote prior to doing anything else. Okay, so the vertical asymptote is going to be what for this problem? Very good. And remember that it's an equation, it's a line, and it's x equals -3. The horizontal asymptote is going to be what? It's actually going to be -2 because we're not setting it equal to 0. It's that value by itself. And so it is y equals -2. So what you're going to do is, once you know that, you're going to go through questions 1 through 5 and you'll be able to pick true or false based on knowing this information. So that means 2 of them are going to be true and the other 3 are going to end up being false. Make sense? Okay. All right. That's it for the first one we're going to talk about. Okay. The next question that we are going to talk about here is this problem. It says solve f of x equals g of x, and then they give you what f of x equals, and they give you what g of x equals. And so the first thing we need to do is what? Yeah, set them equal to each other. So this is f of x, this is g of x, and we set them equal to each other. 15 over x plus 2 equals 3. Now that we have that, what do we do with all these problems when we are solving? Yes and no. So we want to find the LCD, and we also want to know what are my extraneous solutions. And so what would be the LCD for this problem? Good, x plus 2. And then what would be the extraneous solutions? Very good. X cannot equal -2. So now that we know the LCD, and because there's an equal to sign, we can eliminate our fractions by multiplying by the LCD. So I'm multiplying x plus 2 to both these terms. So even though 3 isn't a fraction right now, we could make it a fraction, but just make sure you're always multiplying it to every term. And so what happens here now is that the x plus 2's on the left side there, those eliminate, and we're left with 15 equals, and then here, what will I do? Distribute. So 3 times x is 3x, and 3 times 2 is 6. Now what will I do? Good. Subtract 6 to both sides. 15 minus 6 is 9. 9 equals 3x, and then last I'll do what? Divide by 3. And so what does x equal? 3. And we just want to double check it doesn't match an extraneous solution, and so it doesn't, and that is my answer. Any questions?
So would this be one solution?
Yep, so this would be an example of just one solution. Exactly. Okay, number 3. So this third one I'm going to do is our graphing problem. Okay, and so when you're graphing this, and even on your test, you're going to have all these different pieces. Okay, you'll also have the graph, the grid there, which I forgot to put on my document here. But so we're going to start by partially graphing this. And so, and then if you go to, like, when you're looking on your test, I want to go to my vertical asymptotes and my horizontal asymptote questions. Okay, and so we're going to start with that. What are my vertical asymptotes? Very good. So this is going to be x equals -3 for my vertical, and my horizontal is y equals perfect. And so we're going to go on our graph, and we're going to go to x equals -3, and we are going to make our asymptote there. I'm going to do this with a highlighter. And then we're also going to go to y equals -2, and then again, I just like to highlight our asymptotes, which you can kind of see there. All right, so we know that when we're graphing these, the curves are always diagonal from each other, But right now I'm not exactly sure like which quadrants they should actually be in or which areas they should be in marked by my asymptotes. So the easiest way to figure that out is by going to like B, which is finding the y-intercept and finding our x-intercept. So I'm going to mark B here, and we're going to find our y-intercept. How do I find the y-intercept? So for finding the y-intercept, remember that f of x is the same thing as having y, and you would end up plugging in 0 for x and solving for y. So we would write that as y equals 1 over 0 plus 3 minus 2. 0 plus 3 is 3. And so we have 1/3 minus 2. When you're adding and subtracting fractions, we need to have common denominators. And so I'm going to make right now the denominator of 2 really has a denominator of 1, correct? And so what would be my common denominator for this problem? 3. And so I'm going to end up rewriting this problem with denominators of 3. Well, the first one I don't do anything to because it already has a denominator of 3, so I just keep that as a 1. But for my denominator of 1, we would have to multiply by 3 in order to make it a 3. And so 2 times 3 makes 6. Now remember that whenever you have a subtraction sign, we want to distribute it to either the top or the bottom. In this case, I'm going to distribute it to the top, and then that changes to a plus. And so what is 1 minus 6? Negative 5 over 3. And you would want to change that to a mixed number. And so 3 goes into 5 one time, and there would be 2 left over. So that's negative 1 and 2/3. And so as an ordered pair, we plugged in 0 for x, and then negative 1 and 2/3 is my y. This is saying y equals negative 1 and 2/3. So we need to go down to negative 1 and 2/3 and make that point. So it's in between negative 1 and negative 2 on the y-axis. Next, we're going to go to C, which is finding our x-intercept. And so we find our x-intercept by doing what? Plugging in 0 for y and solving for x. So we get 0 equals 1 over x plus 3 minus 2. We solve this one just like we've been doing almost all of our fraction equations this unit, and that is by finding the LCD and our extraneous solutions. And so what is my LCD on this problem? Good, x plus 3. And my extraneous solutions would be, very good, x cannot equal negative 3. So now I'm going to multiply every term by x plus 3. And when I do that, what is 0 times anything? 0 equals the x plus 3's cancel out, and I'm left with a 1. And then this is a negative 2, and I'm going to distribute it through that parenthesis. So negative 2 times x is, and negative 2 times 3 is. Then we combine like terms, right? And so I'm going to have 0 equals, and 1 and negative 6 makes negative 5 minus, I don't know what I did there, minus 2x. And then next I would, or add 5, do the opposite. And so we have 5 equals negative 2x. And then last I would divide by negative 2. And so again, I change that to a mixed number. And I get x equals, 2 goes into 5 how many times? 2 times with 1 left over. So that's negative 2.5. Or as an ordered pair, that'd be negative 2.5 comma 0. So this is saying x equals this value. So on the x-axis, we go to negative 2.5 and make our point. So based on having our x and y intercepts, that's telling us where that curve is. And so we can go ahead and make our curve there. And then we know that the other curve is diagonal from that. And so we can go here and make our other curve. We've done the tough part of the problem. Okay, so now moving on to D, it says state the domain. So remember, domain's going from left to right. And so therefore my domain is going to be what?
Negative infinity.
Negative infinity, and it stops at our asymptote there, which is at negative 3. And then it starts right back up again at negative 3, and it goes all the way till, very good, For our range, we're going low to high. Smallest has an arrow, which means it would be negative infinity. So starting here, negative infinity, and it goes all the way up to which value is right here? Negative 2, and then it starts right back up again at negative 2 and goes to positive infinity. We already stated our vertical and horizontal asymptotes. Next, it asks us on which intervals is it increasing. So we read graphs just like we read books, going from left to right. So starting at the left, this is going down. And then we start back up again, and this is going down. Is that ever increasing? No. So right here, that's none or no solution or whatever. But you need to state that nothing is happening. It's not decreasing, or not increasing. Sorry. Now the whole graph, as we just kind of talked through, the whole thing was decreasing. So therefore, whenever you're talking about this, you're stating your domain. Okay? And so it's decreasing starting at negative infinity, going all the way till we get here at negative 3. And then we have again our union, and it's going from negative 3 to positive infinity. And I'm going to just rewrite that here again real quick. And so that's I, and that was negative infinity to negative 3, and then negative 3 to positive infinity. Okay, for J, it says state the intervals in which the graph is greater than 0. This is where you might even want to get a note card out if you needed to help yourself. But greater than 0 is above the x-axis. And so it is only greater than 0 at this portion right here. Okay, and that portion is starting at the asymptote, which is at what value? Negative 3. And it only is above 0, greater than 0, to that point, which is at negative 2.5. So that is the only time that it is greater than 0. Now for K, it says when is it less than 0? Well, the graph is less than 0 with everything right there. So starting, it's less than 0, starting at negative infinity, and it goes all the way to our asymptote, which is at negative 3. And then it doesn't start back up at the asymptote, it starts at that point where it's going below the x-axis. And so that value is what? Negative 2.5, and then it goes all the way to positive infinity. So that is where it is less than 0. Do we have any questions there? Okay, number 4. So on number 4, it has an equal sign, which anytime you have an equal to sign, you know that you're solving for x. You're finding a value for x. Whenever we're doing these, we want to, when we're finding a value for x, we want to find our LCD and also our extraneous solutions. How will I find my LCD on this problem? So you want to factor any of the denominators that you can factor. So can I factor this? No, but I'm going to put in parentheses to remind myself that's all stuck together. Can I factor this one? Yes, because it's a difference of squares. Good, and it factors to be what? Good, x plus 1, x minus 1. And so really, that is gone now, and we just have that factor. Are we good with that? So based on that, these both have an x minus 1s, which is great. We will just need one x minus 1. But then because this also has an x plus 1, we also need an x plus 1. Okay? What will be my extraneous solutions based on that being my LCD? Very good. X cannot equal positive 1 or negative 1. What's next? What do I do?
So x plus 1, x minus 1, and the two fractions.
We're going to do x plus 1 and x minus 1 next to every term. Now, something to be careful of here, and this is where a lot of people make mistakes, is that there are actually 1, 2, 3 terms. And so we have to multiply every single term by the LCD, including this one. Okay? So I'm going to write x minus 1 and x plus 1 next to every single term. Okay, so on the first term, okay, what happens? the x minus 1's cancel out. And so we are left with 2x times x plus 1. And some of you go ahead and multiply it through by 2x at the same time, which is fine. For this one, I'm not going to. Then we have our plus sign here in the middle. On this one, all the x plus 1's cancel out, and I'm left with x minus 5. And it doesn't have to be in parentheses, but you could also write in parentheses. And then here, nothing will eliminate, and so I have x minus 1 and x plus 1. So next I'm going to distribute and simplify. Are we okay up to this point? Okay, so we distribute. 2x times x is 2x squared. 2x times 1 is 2x. And then I have a plus. If I distribute a plus, it doesn't change anything. So I still have a plus x and a minus 5 equals, over here, if I distribute, I get x times x, which is x squared. X times 1 is 1x, or just x. Negative 1 times x is negative x. And then negative 1 times positive 1 is negative 1. So if we simplify and combine like terms on each side, this is gonna be 2x squared, and then 2x and x is 3x minus 5. Over here, I have x squared, and then x minus x, that cancels out, and then we have a minus 1. Anytime we have x squared, we want to factor. Okay? And so in order to factor, it has to be set equal to 0. Good. And so I'm going to go ahead and subtract x squared, and I'm also going to add 1. Okay, so these cancel out, and we end up with x squared plus 3x minus 4 equals 0. All I've done is combine my like terms, set it equal to 0. Next, because I have 3 terms, how will I factor? Our trinomial factoring, right? We are going to find our multiplication number, which is negative 4, and our adding number is positive 3. So what numbers will end up working? 1 and 4. And one of them has to be a negative, so which one will be negative? 1. Because when they subtract, we want to get a positive 3, and then when they multiply, it'll be a negative 4. We can use the shortcut because the coefficient in front is 1, and so because this is x squared, we split up the x's. And then here we will have a minus 1 and a plus 4. When we set each of those factors equal to 0, we end up getting x equals 1 and x equals negative 4. We check those with our extraneous solutions, and we find that 1 will not work. So therefore, this answer is only x equals negative 4, which means how many solutions are there? Only 1 solution. So even though we found 2 solutions, because 1 is an extraneous solution, it doesn't work, and there's only 1 solution. Do we have questions on this? Okay, moving on to the next one. Okay, notice here on number 5 that there's no equal sign. So we're not solving for x. We don't care about extraneous solutions. We just want to combine these and so that they're one fraction. The only time we're solving is when there's an equal sign. There is no equal sign. Okay, what do you notice about these denominators?
They're not the same, but they're not the same.
Right, they're opposites, right? They're not quite the same. What could I do in order to make them the same? Yeah, so you could factor out a negative 1 from here. Okay, and if I did that, if I took out a negative 1 from here, this 2 becomes a negative and the x becomes a positive. Do you guys agree with that? So now are these the same? Yes, but there's still a negative here. What can I do with that negative? Yeah, so anytime you have a negative that's either here in the middle or wherever, you have the option of distributing it to the bottom or distributing it to the top. So we're going to take that negative and we're going to distribute it to the top. There's only one term there, but if there was multiple terms, you have to take the negative to every single term. just like I took the negative out of every single term here. Okay, so we bring that to the top. This becomes a negative. Once I do that, this can now become a positive. Now we have like denominators, and so my denominator is x minus 2. Can I combine these, x squared and negative 2x? No. So we just write it as x squared minus 2x. Now that we have a single fraction, can I factor or do anything right now? Yes. So right now these are stuck together, right? Because we have minuses there connecting them. But on the top, can I do anything? Yes. We can factor out an x. So when I do that, I divide each of these by x. I end up with what? Good. My denominator is still x minus 2. And now that I've done that, what happens? X minus 2's cancel out, and my answer is just x. Any questions? Okay, this is going to be our last problem that we're going to do. Okay, so here is another function here. They said given f of x equals 6 over x minus 2, and I don't know that I can't spell there, and g of x equals 5 over x minus 3. Solve the equation for f of x equals g of x. So what will I start by doing? Very good. 6 over x minus 2 equals 5 over x minus 3. There is an equal sign here, which means what? We're going to solve for x, right? And we also have to be aware of extraneous solutions. Okay, so what is my common denominator for this problem? What is my LCD?
X plus 2, or x minus 2, x plus, or x minus 3.
Very good. X minus 2 and x minus 3 is correct. Based on that information, what are my extraneous solutions? Very good. X cannot equal positive 2 or positive 3. Because there's an equal to sign, we can eliminate fractions by multiplying every term by the LCD. Notice on this problem, there are only 2 terms. But every term we multiply by our LCD. So I'm going to multiply the first one by x minus 2 times x minus 3, and my second one by x minus 2 and x minus 3. When I do that, the first term here, the x minus 2's cancel out. And for now, I'm just going to rewrite this as 6 times x minus 3. On the next one, the x minus 3's cancel out, and I'm left with 5 times x minus 2. Now, in order to solve for x, we'll distribute the 6. 6 times x is 6x. 6 times negative 3 is negative 18, equals 5 times x is 5x, and 5 times negative 2 is negative 10. From there, we want to combine like terms. So I'm going to subtract 5x to both sides. Some of you at the same time, you might even add 10 and make this set equal to 0. So I'm going to do it this way. 6x minus 5x is 1x, or x, and negative 18 and positive 10 makes negative 8. X minus 8 equals 0. Well, I can't factor or do anything with that. It's just, there's my answer, right? X minus 8 equals 0 means x equals 8. And does this match any extraneous solution? No. So that's my answer. Any questions?